Welcome to the second class of our Design Essentials. Today we will be covering CAD. Are we getting mic okay? I understand we had some issues last time with the mic. Are we getting it streamed okay? Fantastic. I've left this from last time. Again, the goal is primarily here to teach students and convey the best mechanical design practices for CAD, and that's what we're going to be focusing on today. Last time we talked about mechanical principles, and this time we will be talking about OnShape parts and basic controls, such as sketches, design intent, and whole wizard, and then next week we will look at OnShape assemblies. A couple of disclaimers to start off. We are using OnShape for a couple of reasons. OnShape is free and easy to sign up with. OnShape also encourages collaborative working. Just like Google Documents, it allows you to have multiple people editing a single file at the same time, which is not something that any other software I have seen does. However, OnShape encourages you to put multiple parts in a single part file. That's not something we will be doing. I don't know any other software that does that is used professionally. So we will be only using one part per file. We will also be using the metric system. Can anyone guess why we would only be using the metric system?
Because it makes more sense.
That is. I also prefer my units of measurement to not be based on the lengths of seeds, but we will be using the metric system because that's what our purchase parts are in. And so it's easier to design around purchase parts and not have to deal with both SAE systems and metric systems at the same time. OnShape allows you to do branches, which is something that coding softwares typically allow you to do. You can have multiple versions of a single part being worked in parallel and then bring them back in at the very end. We'll talk about the importance of fully defined sketches and eliminating your blue lines. And there are different types of modeling practices, such as top-down modeling or parametric modeling, where you start with a full detailed sketch of everything you want to make and then extrude and cut from there, as opposed to building one feature at a time. And then there's also in-context modeling, where I am editing one part in an assembly and linking that to another part. So if I change that part, it automatically changes this one. We're going to avoid doing that because it tends to be very cumbersome for any type of computation for the computer. We probably won't be doing top-down modeling. I generally model how it would be manufactured. So if I'm cutting a plate, I will start with a solid plate at whatever size, outer dimensions I have, and then add features to it. And that workflow has worked well for me, keeping manufacturing in mind, and I feel in the type of production setting that robotics and FTC lends itself to as professional skills is probably the best way of learning. A couple of features we're going to talk about, and that would be in OnShape. So we're going to switch over to OnShape here. This is the OnShape interface. When you first start, I have all of my parts down here, and we are going to create a new document. And we want a name for this document. What do we want to name our document? That is a very long name. There you go. We're going to name it ADEC base part. And we get a workspace. It is a blank workspace with a couple of useful items here. Those would be the three planes of orientation on the part and the origin. The origin is where all three of these planes cross each other. I can also highlight them over here. OnShape allows you to click parts and you don't have to hold control. So it encourages you to click something and then click something else, and it has a little 2 by the mouse there so that you know that you have 2 things selected, and when I click this it'll become 3 things, and if I want to deselect it I have to click elsewhere, or I could select that same part again. Going through the items here, as we talk about these items, we're going to look at why you would use them more than how you use them. You can find lots of videos on how things are used, not so many videos on why you would use a particular feature versus another. Another valuable point is in OnShape is if I sit here and hover over an item and I hold my mouse still, it will give me a description of what that item does. So looking at extrude, this is going to be what 90% of your items are going to be. Extrude is how you make something positive or cut away something in a linear direction, as opposed to a revolve, which does the same thing but around an axis. You won't really use a whole lot of sweeping, lofting, or thickening in our designs. Those are more advanced tools that you don't really need to know a whole lot about right now. If I click this little down arrow, there is more, such as enclose. Again, advanced tool you don't need to know. You will use lots of fillets. It is not pronounced fillet. It is pronounced fillet. I got fussed at the very first time that I said it was a fillet, and so I'm going to head everyone off there and let you know that it is pronounced fillet. And then you have chamfers here. We use lots of those to break edges, because edges are weak points when you look at parts. They're stress concentration points. Drafting is something you won't use a whole lot of. Ribs you may use, although you could make them with an extrude. Shell you may use if you're doing some kind of modeling and you want it to be accurate to what your physical part is, with 3D printed parts typically being hollow, but you probably won't use it here. Hole we will use a lot of. Anytime you need to put any kind of fastener in, or put any bolt, any shaft, anything like that, dowel pins, you should use the hole feature, and we'll get into why that is later. External thread you don't typically need to use. Very rarely are you printing your own actual threads, and most times you don't even need to model the threads in. If you model the threads in, you're going to slow down your model. So don't model the threads in, just make it the right size using the hole feature. Linear patterns, and by extension circular and curved patterns, very useful. Saves you a lot of time if you design one thing and just pattern it. It also is very good for the software because it's less computationally heavy. It doesn't have to recalculate every surface every time. Similarly, mirror, if you're making a symmetric part, very useful. And most of these other ones we're going to ignore, especially the surface modeling, because there's no reason for you guys to be doing any kind of surface modeling in FTC. Reference geometry, very powerful. If you use it correctly, it will give you a very robust model that allows you to make changes on the fly without getting what's called a bleeding tree. A bleeding tree is when you make changes and you update your model, and over on the side here it gives you all sorts of red and yellow saying you have lots of problems. It's called a bleeding tree because this is your design tree. Frame, we probably won't get into right now. We may get into it next class. Frame is used for making extruded parts very quickly. And sheet metal, you won't really use a lot of these here unless you're actually getting sheet metal parts made. So from there, we're going to start. The way that OnShape prefers you to model things is to make the sketch first and then tell it what you want to do with that sketch. So we're going to start with a sketch, and it's going to ask what plane do we want to start in. Now generally when you model a part, you want to model it as if it was sitting in the same orientation that you would have it in real life. So if I'm going to make a side plate, I probably want to select the right plane because it's going to be on the right or the left of the robot. I can also come over here, and this allows me to rotate it. So I have my settings set to SolidWorks standard because that's what I use professionally, but I can zoom in, zoom out with the mouse wheel. If I click the middle mouse wheel in, it lets me rotate the part. Or I can do all of that over here with these settings. I can grab this and select looking at the bottom face. I can rotate around, look at the right plane, and since we're sketching on the right plane, this is where we're going to start. I know I'm still in my sketch because it gives me the sketch right here. Looking at the sketch features, or the sketch options here, 90+% are going to be these first 4 items here. That's how you make your geometry. You have a line, as it states. You can make a rectangle. You could also make a rectangle out of lines. This is just a faster way of doing it. There's different types of rectangles, and it tells you what it is. Corner rectangle gives me 2 points in the corner, and that's my rectangle. I hit escape to get out of that tool, otherwise it wants me to make more rectangles. I can keep making rectangles. When I click and drag, there's 2 types of ways of clicking and dragging. I can go left to right, in which case I get a blue box, or I can go right to left, in which case it's orange. Does anyone know the difference between these two?
The blue box only selects the things that are fully inside the box, and the orange box selects anything that's touching the
That is correct.
orange box.
The blue box, only things that are fully inside the box. So I am fully covering this line, but I'm not fully covering these 2 lines when I select this, and it will only select that. However, if I go the other way, everything that's in there, whether it's fully selected or not, or fully covered or not, is going to be selected. So I'm just going to go this way and hit delete to get rid of those. Center point rectangle starts at a center point, bring it out, and you'll notice that all of these lines are blue. Hit escape to get rid of the tool. And if I wanted to know why they're blue, it's because I'm not fully defined. I can change this however I want. So if I wanted to fully define it, there's a couple of things that you use to fully define it. The first one is the dimension tool to give it an actual dimension. Right now I'm in inches. We're just going to deal with inches today, but I can change my standard, I believe, down here. Nope, these are mass properties. You have to go into your settings to change what your standard is. I could type in 55 millimeters, and it'll do the conversion for me to inches. So that's 55 millimeters or 2.165 inches. You'll see that it is still not fully defined because I've only given it one dimension. So maybe I wanted to make it a perfect square. I'll click here, I click there, and I give it a relationship. Make them equal. Now it's a fully defined sketch. So I'm going to make this bigger. We'll make it 4 inches. You don't have to type the inches. If it'll use your base unit if you don't. Now that I have a sketch done, I'm going to hit the check, and it just gives me the sketch. If I wanted to do something with it, I can come over here and hit extrude, and it's going to ask me what I want to extrude. I can either click that line, or I can come over here and click sketch 1. And if I rotate a little bit, it gives me a couple options as to what it wants me to do, but it gives me a preview here first. We're going from this plane straight off the top. Generally, when you design your parts, you want to keep the origin in the center of the part. So to do that, you have a couple different options here. Blind means for some distance that you specify. If you have more geometry, you can select up to next, so it goes through everything until it hits an opening. You can select up to a face, up to part, up to vertex, or through all, which will be through everything. It's not something we want to select here. When I select blind, it gives me the option right here, but I can make it symmetric, and it'll give it 1 inch overall in both directions. Draft is something we won't use. You can see it adds an angle from there, and I can flip the direction that the draft is facing, but you shouldn't be using draft in this modeling system for pretty much anything you do for FTC. So we're going to make it 2 inches thick, and to accept that, you can see it selects new here, and it's solid. You just hit the check, and now I have a physical box in here that I can manipulate and look at. And if I wanted to make another sketch, I can either sketch off the plane, I could sketch off the face, I could sketch off a different face, and which one you select depends on what you are trying to do. If I want something to be symmetric across the middle, say I want to make this a C shape instead, I can come in here, I can make a new sketch looking at the right plane, do a 2-point rectangle, go from the bottom edge to this edge here, and you'll see it is also not fully defined. So I can select that edge, this edge, and make them coincide. Do it on there. If you're ever in any doubt of what you are missing in terms of relations, just grab it and drag it. And you could always press, if I drag it down here and I had some complex geometry and it messed it up, I can press Control Z. Maybe I can't. It helps if I press Z. press Control Z and it'll undo the last thing that I did. OnShape.
One catching up. Katie's entered, y'all good?
Yep.
See shapes here. So this purpose.
OnShape automatically saves every click that you do. And if you ever wanted to look at what those clicks were, you can come over here to Versions in History, and you can look at everything that you have ever done and show changes. You could also create multiple versions. We'll get into that elsewhere. So we're going to make these two coincident. Again, we're going to give that one, we're going to select this point and select that point and make those the same. So now it's halfway through. That sketch was made on this plane, and you can see it is halfway through the part if I rotate it around. It's not on this surface, it's not on the bottom, it's halfway through the part. If we want to cut that, you can select your sketch, you click Extrude, and you click Remove. And if we want to, again, make it symmetric, 1 inch instead of the 2 inches, we just click that check mark. Now, I can come in here and I can make this, instead of a 4x4, I can make it a 6x6 by double clicking, hit that check mark, and it automatically updates it. So if I always wanted this slot to be to that midpoint of this line and the full length in the middle, that is one way of accomplishing that, is by using my planes instead. Now let's say I didn't want it to always be on that side. I always wanted it to be a cutaway from this face instead. I should be able to, let's see if we can edit, see the sketch plane. I can change the sketch plane from the right to this surface here. It brings it up, I hit check, and it gives me the cut up there instead. So if I come back and I was to change this dimension from 2 to 3, it maintains that cut on that top edge instead of in the middle. It's what we call design intent.
I think you just exploded Mr. Austin's brain.
It's a good explosion.
In what way did I explode your brain?
I didn't know you could move the reference plane, the sketch from one plane to another.
Right now, we're actually still a symmetric cut. So this, even though it's set at 1 inch, if I click right here on this line, let me zoom in a little bit so I can actually grab the line, it gives me the length right here of 1/2 inch. So if I go through and I edit that instead and make it no longer symmetric, you'll see that it actually makes it the full inch right there. I can also select this sketch. Say I wanted to do something else with it. Maybe I should grab the top sketch instead. No, we're going to select this sketch. I can select this sketch and do something else with it. I can tell it, again, that I want to, oh, I selected a face. Select that sketch, extrude, and it allows me to use that same sketch again for a different feature without having to change it. What that means for me, though, is if I do change it, it's going to affect both features. So generally, you will not use one sketch for multiple features because it's going to affect them all across the board. Sometimes you want that, sometimes you don't. There's this thin, solid, surface, thin. Solid is what we've been dealing with. It gives you a solid part. If I did a section cut, it would show that it's still solid all the way through. If I click surface, again, this is something we're going to avoid because surface modeling, while very powerful, is not something we want to do because it's a wormhole, a can of worms, excuse me, that you don't want to get into. It's a wormhole too. Somehow you end up spending lots of time and accomplish nothing.
Wait, we can use it to travel to other parts of the galaxy?
If you really want to, you can. But just like in an actual wormhole, you'll probably get stretched as you go through, and it won't be a very pleasant experience. Thin, on the other hand, we can't see what the sketch is doing right now. We kind of know, but if I wanted to see, I can just come over here and click that eyeball, and it shows me this sketch. So thin wants me to select faces and regions to extrude. It basically takes a line instead of an area, and I can select that line I can give it a thickness in one direction. If I look at the top, it's only going one way. I can give it a thickness in the other direction, and then I can tell it, just like an extrude, how far I want it to be. So this is really powerful when you're making ribs. If you want to make a rib between something, you draw a single line and you make a thin extrusion, and it will give a thickness to that line. So when you make lightning pockets, you could do a big cutaway on everything you don't need and then draw single lines and do a thin extrusion. Thin extrusions can be difficult to modify the dimensions on, but do have their place. Another way of doing a thin extrusion would be to sketch. So I've selected the top face before I selected sketch. And so it knows where I want to put it. If I hadn't done that and I just selected sketch, first thing it wants to know is where is that plane. So I'm going to select this top face. And we're going to select this. I guess this is technically the right face. I could do a single line, and you can see how it's giving me these options of what it wants. That little symbol right next to me is the midpoint symbol versus the coincident symbol. So here it's anywhere along the line, but midpoint mean that it's exactly midpoint of that line, and that's what I want. I can hit escape, or when I draw this line the first time, I click, and then I'm going to double click instead, and it doesn't drag off of that original point. So I don't have to hit escape. I can just double click. Yes, sir?
Was the first click that you clicked in the midpoint of the left side?
I did.
Okay.
So this was a midpoint, and I don't have to select midpoint. I just did that because that's where I want it to be. But the difference there and here is that this is not a defined line, but if I click it, it does show me that I do have one relation, and that relation is perpendicular to the other highlighted edge here, which is this edge right there. When I hover over this, you can see it highlights both of them. So if I delete that by clicking it and deleting it, I can now drag this, and it is no longer perpendicular. I can make it perpendicular again by coming over here and saying, make it horizontal. So there's lots of ways of accomplishing the exact same thing. Excuse me. We have an option of offsetting the line right here, because we were talking about thin extrudes before. Another way of doing that is to come into this offset and select that, and it's going to ask you which side you want to offset it, and I can click and drag this either way I want, or I can click this number right here. It looks like I have selected the whole face instead, and make it 0.5. I did, in fact, select the whole face. So we're going to unselect this and delete those excess ones. So I can make it the effect of thin extrude by doing an offset, or I could just do a thin extrude. It's two ways of accomplishing the same thing. Looking at holes, or circles, excuse me, there's different types of circles. Ellipses are useful. Most times you're going to do a center point circle, which it wants to know what the center point is. We're going to select the center of this line, and we're going to drag it out. If I hit check, it closes the sketch, and now I can do something with it. But my sketch is not fully defined, so we're going to go back into it and edit it. And I know it's not fully defined because I have blue visible. When I say tangent, who doesn't understand what tangent means? It's okay if you don't. I'm going to explain it anyway, just in case you don't. Tangent is the concept of you have on a curve, just imagine that's a perfect circle. If I was to draw a line that touched that circle at exactly one point, and only one point, otherwise this is a perfectly straight line. Use your imagination. This is what's called tangent. The opposite is normal, which it touches at one line, but it is perpendicular to the tangent. So this is called normal, where it goes perfectly out from. Tangent, it is touching at exactly one point, effectively parallel to. Tangent is a reference that you can use for, or a relationship you can use to make 2 points touch right here. And now I don't have to dimension it at all if I know that I want it tangent to that top edge. So I've put no dimensions on this, and it is a fully defined sketch. If I was to try and do an extrude from this sketch, to do a cut or do remove, it's going to take a guess at what it wants, what I want it to do. And I can come over here and select, maybe I want that section cut away only. Maybe I want those two sections cut away, and you can see the previews that it's giving me. But a better way of going about it is to guarantee that there's only one thing that I can select. And in this case, to do that, I'm going to make this cross line, because it creates different boundaries, a construction geometry. What that means is it knows the line is there, but it doesn't include that line as part of the contour. So if I hit check and I come here and extrude, you can see that it now knows that I want a circle. I don't want any of these other sections here. I want a circle. And if I do remove, it's giving me red. Why is it giving me red? Who knows?
Because there's an error.
It's not an error yet, but it will be an error. And you can see that it's red there. But why is there an error? What error is it giving me?
There is a line on the circle that is tangent to, or there's this point on the circle that is tangent to a line on the rest of the extrude, causing an infinitesimally small point where, or small bit where it is.
That is correct. It is called zero thickness geometry. At this point right here, where that touches, this is so small that it technically has no thickness. And the modeling software does not like that. Does not like that one bit. So it doesn't want you to do that. So what we can do is, instead of extruding, we can go back into that sketch. Edit sketch. And we say we don't want this to be tangent anymore. Now it's underdefined again. Well, let's just get right back here. Let's give this a dimension. Make it 2 inches. That way it's not touching those edges. And then we're going to do actually a revolved cut. And it wants to know, what is my revolved axis? Well, I'm going to select. See if it lets me select the, nope. It doesn't like that it's construction geometry, which is a shame. SolidWorks lets me do that. So we're going to make this non-construction geometry. And we're going to try it again. Select edges I want to cut here, revolve axis there. Oh, did not automatically move. Revolve axis here. And we're going to add. It did not like it. And the reason it did not like it is because it covers itself again. So if I was to take this circle and spin it around this axis, a full circle is going to make that geometry twice, because this half is going to spin 360 and this half is going to spin 360, and so you'll end up having 2 circles on top of itself. So we can solve that by editing the sketch, and we only need half of this because we're spinning it around that line. So what we're going to do is we're going to click the trim tool, which has different types of trim, but we're going to click the trim tool. We're going to trim that little piece off right there. Click the check. We're going to come back into this revolve feature, and now you can see that it actually has something for us to do. But it does not like it. I do wish it would tell me why it wouldn't like it.
You're on the surface tool for some reason.
That is why I did not like it. Thank you. I did not see, and I can actually remove that. And it gives me a preview of what that would look like. Now I have a perfect dome, or half dome, cut away. And if I select it, you can see how deep it goes. So we can put a little divot in it, just like that. We're going to do a new sketch on this face. So we've looked at lines, we've looked at corner rectangles, or rectangles in general, we've looked at circles. Arcs are a way of doing a partial circle. So let's say on this top face, I wanted to cut away this corner. I can do an arc. This is a 3-point arc as opposed to a tangent arc, which selects a line first and then a point. There's a center point arc, which I select the center point, how far out I want to go, and I've already set the diameter here and where I want to go, but because none of this is defined, it doesn't really matter. You can do a partial ellipse. So I can define how much of an ellipse I want and how much of that line is actually existing. So I'm going to get rid of a couple of these. If I wanted to make these two items tangent, I can just select them, press tangent right there, and you see it brought it down. I can drag it out. Maybe I want to select these two and make them match up. Same for these two. And then I want these to also be tangent. So it's underdefined because I haven't given it a radius, but it is given a perfect curve to this corner. So I'm going to dimension it at 1. And if I tried to cut this right now, it might cut, but I'm going to finish the contour and say that I want to cut this whole corner off. From there to there to there. I'm blue, as you can see here. So I'm going to make this piece vertical. And now I am a fully defined sketch of this corner. But maybe I don't want to just cut the corner off. Maybe I want to cut both corners off. So I can do a mirror inside the sketch. If I'm going to do that, it's going to ask for a mirror line. I can select this plane. Select the entities to be mirrored. I'm going to select all of these. And now, using one dimension, I have a fully defined sketch to make both these corners. The goal when you're modeling should be to use the least amount of dimensions possible. You want to use reference geometry as much as you can to define what you're trying to do. So we will cut those two pieces away. And we're just going to go through all. So that's through all in one direction. And if I do symmetric, it'll go both directions. So now we have a nice little part here. We're going to go ahead and rename our part too while I'm thinking about it. You should always name your parts. But what are we going to name our part? No answers? Fred. We can name our part Fred. But what happens if there's another Fred?
Fred 2.
You're gonna start naming them Fred 1, Fred 2, Fred, so on and so forth. So so I highly recommend you coming up with a part numbering sequence or a system. This is one that I came up with on the fly that you could use if you so desire. That starts with the year, the initials of the team, and then a space and 4 numbers. The first number that is non-zero, you have a question?
Can they use an emoji? A cheese emoji?
I will tell you that SolidWorks will not let you use spaces in the name. That's not true. There's something it won't let you use. Slashes? It won't let you use slashes. Quotation marks. I think it lets you use dashes now. It used to not let you use spaces. And the way around that was to put underscores. So I think if you tried to do a space, it would throw up an error at that point and say, hey, you can't name it with any of these special characters at all. So it didn't let you save it. But I think if you tried to do it, you might break the OnShape system. But you're more than welcome to try. It's your time that you're potentially wasting, not mine. So what we do at work is when we have assembly files, we start them with 0. And when we have part files, we start them without 0. And so I can look at a file number and know exactly, without reading anything else about it, without even seeing what the file is, I can look at the name and say, this was from year 2024 for team Microchips and Queso, and it's an assembly file. Or it's a part file. We also go a step farther, and I have an Excel list grouping part numbers. So my 1,000 to this, and then 2,000. This might be too small for people to see. This would be something like the frame. And maybe this is the camera system. And I group these ahead of time. So if I am working on the camera system or the frame, I already know what part numbers I need to be using. So if I have this document, I can look at a part number or an assembly file and know what subsystem it goes on as well. So you can ascertain a lot of information from the part number alone if you have a standard part numbering system. Or you can just name things Fred, Fred 1, Fred 2, Fred with the curve cut. It's really up to you as to which way you want to go. Well, we lost it again.
Windows tab,
Windows tab.
and then desktop too.
Fantastic.
Aw,
It-
canceled. Windows tab. There you go.
Fantastic. So I have SolidWorks settings. Unfortunately, I don't know what the OnShape standard settings are to manipulate the part. If anyone knows, they are welcome to speak up now for rotating, moving the part around, zooming in and out. Is it the same?
It's different.
I thought it was different.
It's just the mouse is converted.
Rotate is right click and drag, zoom in and out is scroll wheel. I think left click and drag does nothing, yeah. Or yeah, it just allows you to select things.
If I control and scroll wheel, center scroll wheel click, it lets me pan. That's what this is. So this is pan, that's zoom in and out, and this is rotate, just for reference on what those mean. Okay, let's see what tools we haven't used yet that we'll go into. We've talked about center points, we've talked about circles, ellipses, inscribed versus circumscribed polygons. We'll look at this real quick. We will go back to this view. So as I'm creating a polygon, you can see that it has a whole bunch of sides here. And then I can move this around. The farther away I go, the more sides it has. The closer in I go, the less sides it has, all the way down to 3. So I can make it a hexagon here, real quick and easy without having to draw it out. I'm going to get off of that. And inscribe means that the tangent of this circle is touching the center points of all of these lines. Circumscribed would be the same as this circle here, where I went to the outside. So that's circumscribed, that's inscribed. It really doesn't matter, but typically when you're looking at a dimension for something like a hex nut that you might be using, you're going to have a flat-to-flat dimension, not a point-to-point dimension. So an inscribed circle is generally going to be better for that. And that way, when I dimension this circle, it's the same as me clicking on that line and saying, make it 1.5 inches. So we're going to go ahead and dimension some more points. And I can make this as cluttered and as busy as I want it to be. Or I can put some reference geometry in. In fact, we'll do both. We will get off of this. And actually, we'll make this from here to here, 0.75. And I will do another polygon over here using reference geometry instead, so you can see the difference. So those are both fully defined the exact same way, and in one case I have 1, 2, 3, 4 dimensions, or I could have 2. And the more complicated your geometry gets, the worse that is going to get. So if I have a huge single sketch for my entire side plate with all my holes and everything, having a whole bunch of dimensions all over the place makes it very hard to work on. Whereas having a couple dimension makes it much easier. So I'm going to go ahead and extrude this, and we will remove half. And if I wanted to edit that or see what those dimensions were, and I have a whole bunch of dimensions all over the place, I wouldn't be able to see these very easily. Whereas I could see what's going on with this one much easier. So use your reference geometry and your construction lines. We got some chickens outside making some noise. Splines are a great way of getting complex geometry, but we're not going to really cover them here. They can be very tough to work with. So I think it's better when you have nice, straight geometric lines. Points are incredibly useful. In fact, we are going to start using some points now. So I'm going to go to the right, and why don't we come to the back side? We'll look at the left. So let's say that I want to mount a motor. I am going to start by going, I guess I was already in here. We're going to go to go build, I always forget there's no U. Yeah. Wow. It's just missing the U. Why are we going to go build a? It is a fun store to go to.
CAD files on it for you to put into OnShape.
That is correct.
Oh no, Net nanny.
My net nanny says that I'm not allowed to. I'm not allowed to go build a. Oh no. Can I click request access?
Net Nanny says you can't be an engineer today.
I don't think I'm refreshing the page. Yikes. We have parental locks on. Well, I was going to get dimensions from the motors. So if someone wouldn't mind going to go build it for me and collecting on one of these motors.
Yeah, Mom has it. She's turning it off.
What dimension do you want for the motor?
I need some of the dimensions related to the mounting pattern.
The holes are 24 millimeters from edge to edge of the hole.
I don't know how to explain it.
So,
It won't let me zoom in.
we will draw a picture. That way everyone else can follow along. Typically, there are two ways that motors are going to give you a dimension. Most motors, you're either going to be square or round, but they will have bolt holes. In this case, the motors for have a bolt pattern like this, and this is your shaft coming out the middle. They will either give you the dimension here to here, which typically is going to be the same as here to here, or they will give you what's called the bolt circle. So if I was to draw a line, a circle that is concentric, meaning it shares the same center point as all of these, the outer circle and the shaft, which would be this center point here, it will give me a diameter of the bolt circle. Usually it'll give you one of the two.
The width from center to center is 16 millimeters, and then the length from center to center is 24 millimeters.
I also need,
It's 16 millimeters on both.
The 24
Oh,
is
I was looking at the wrong
16
hole.
by 16.
My bad. It is 16 that way. I was looking at the wrong hole.
that's why I wanted to pull up the picture if it was possible. So I'm not surprised that it is the same. Typically it will be the same unless you have an oblong motor. So that's 16 in each direction, and I also need I'm going to not put it where I'm sitting. I need the size of the hole. It'll tell you it on the drawing. You can click on that drawing to make it bigger.
Wait, what do you want to read?
The size of the hole.
4 millimeters.
What does it say exactly?
M4 times 0.7 millimeters, 10 millimeter depth.
So typically you'll see something like this. M4 is the size of the screw. This is the thread pitch. Very rarely will you use a fine thread metric. Almost always it's going to be what's called coarse thread. So this is the size, and then this is the depth of that hole that you have threads to work with. So we're going to go back to our part file, and I've put points in here. Kicking the ground. I am going to draw a box center point rectangle, and I am going to make it exactly in the center here, up to one of these lines. And then I'm going to, if I click and drag, you can see that it gives me the potential for some relations. It's asking me right now if I want to make those horizontal with each other, or in this case, coincident with each other. And I do, so I'm just going to let it go. And the same right there. So I know that I am clicking and dragging and putting these on the corners. So if I drag this around, it will keep those points on those corners. And we know that these are the same at 16 millimeters. And we will give them a dimension of 16 millimeters, which is very tiny compared to our big plate. And so I have a fully defined sketch here. I'm going to click check, and then I'm going to come over here to the hole option. And it wants to know what sketch points I want to select. So I'm going to select these sketch points here first. And then we're going to look at a couple of the different options. So it is metric. It's not standard. It's not SAE. It's not an inch bolt that we're putting in. It's metric. You can choose a simple hole, which is just a straight through hole, a counter bore. If I did a cross section of a counter bore, it has room for the head of the bolt. So if I had a bolt in here, it would sit like this. Turns out it's hard to draw at an angle, but it would sit in there like that. That's a counter bore. As opposed to a counter sink, which is a V groove, and you use with flathead bolts. And then your bolt would sit in here like this. Why would you use one versus the other? That is an acceptable answer, but it's not the answer I was looking for. Because typically you are selecting, the answer was depending on the type of screw you're using. Typically you are selecting the screw last. You're not starting with the screw. So why would you use one over the other? Any guesses? Guesses are welcome. I don't bite. Hard, at least.
To do with the surface area of the head of the screw and the gripping strength of the screw when you torqued it in the threads?
Again, an acceptable answer, but kind of the opposite of what I was looking for. So this screw will have a bigger hex key than this one will, just by design, unless this is a button head. But a socket head cap screw has a deeper key for the Allen wrench than typically a flathead screw will, and it's also usually bigger. So there's more material thickness there, meaning you can tighten this one down better than you can tighten that one. So generally, you want to try and use these. You can't always use these. If my material thickness is, instead of being this deep, if instead it was this deep, and this is all I had, that is a very thin area to try and hold all the strength. Whereas that same type of cut here would give you a lot more material to work with. So if you are dealing with thinner pieces, you may be left with a thin, what's called material condition, as opposed to a much better material condition, meaning your material is in much better condition. So use socket heads where you can. If you need them to be not so protruded or you need things to slide off of them, button heads are good. If you can't counterbore, if you can counterbore them so that it's a flat surface, if you can't and you still need it to be a flat surface, but this is too thin of material with 1/8 inch material is pretty standard. 1/8 inch doesn't give you a whole lot of room for a head of a screw, but there's plenty of strength for a countersink. So that's when you generally use one over the other. That's the difference between counterbore, countersink, and simple is just a straight through hole. There's no angles or cutaways at all. You get to choose your type when you're looking at this. Maybe you want to make it the size to be able to run a tap in it afterwards, which it gives you more information there. One of those things being the pitch. Per our Go Build a Motor spec, the pitch is 0.7 millimeters, which is 0.7 millimeters here. It is a different diameter. You can see the diameter is 0.177. If I change it to fine, I guess for metric it's the same. On SAE bolts, it gets bigger whenever you change it to fine because you need less material there. Most times you're not going to put a tapped hole in a printed part. You're going to put a through hole for strength because your threads will not be there. So we're going to do clearance. How much clearance should we give a bolt? 0.5 millimeter is a good answer. If I highlight this right here, it already says 4.5 millimeters. If I wanted to, I could do a loose fit. I wonder why this isn't updating. There it goes. 4.8 millimeters. I could do a close fit. 4.3 millimeters. Which one do we use? It kind of depends on your printer, if you're printing it, or your machining skills, if you're machining it. I would say in most cases you're going to want to leave it at normal and go with 0.5 millimeter. Where does it start? From the sketch plane. I don't have to start from the sketch plane. As you can see over here, let's move this up so we can see it. It is starting from this sketch plane, and it is going down that way, all the way through the part. You can see it down here. I can instead say that I want to start from selected plane. Maybe I want to start way up here. And you can see it added those holes and it went all the way down through. Maybe I don't want to start way up there. Maybe I want to start down here and go the other way. And you can see it would result in the same thing if I did it that way. I also want it to be through all. Maybe I want it to be blind instead, meaning part way through. I can choose a depth, 0.5. From this plane, you can see I no longer can see the bolt holes there, and they can go through here. They will always have this drill angle by default in it, because if you're manufacturing this out of a piece of metal or a piece of wood, to get that hole, you're going to have a drill, and that drill is going to have some kind of angle to it. It won't mess up your print if you leave it that way. It's fine. If we wanted to, let's go ahead and select this. So we're good to go there. We have the mounting pattern for a motor. But as you can see right now, it won't be very easy to put bolts in this mounting pattern because it's a blind hole. So if we want to edit it, we can edit it here. And we can just, instead of blind, make it through all. Hit the check. And now all of those have been updated with one click. If I wanted to change the size, maybe I read it wrong and it's not an M4, it's an M5. I can come in here and I can just change the bolt to an M5. Hit the check. Now it's an M5 hole. We're going to change it back to an M4. And we're just going to go ahead and do one more thing with a useful piece. I want to make a hole for the shaft. So I am going to make a circle. And I want this hole to move wherever I move this bolt pattern to. So I'm going to use some reference geometry. I'm going to select the center of that bolt pattern and the center of this. So I've made a line here. And I'm going to select that line and the midpoint. That's not the midpoint, the center point. And I'm going to make it a midpoint. So now this circle, no matter where these bolt holes move, will always move with those bolts. Claire, do you still have it pulled up? What is the shaft diameter?
8 millimeters. 7 millimeters flat to flat.
And what is the overall diameter?
8 millimeters.
So it's an 8 millimeter. I'm going to give it some clearance. We'll say 8.5 millimeters. And we will hit. Hey! My mom gave me access.
Thanks, Mom.
Thanks, Mom. Oh, of course it would. Why would you do this, Gobilda? Why are you like this? We can look at the spec sheet. And there you go. And now I can zoom in. So, just so we can cover again what we were looking at. We were looking at the distance right here from the holes to the holes as drawn, 16 millimeter 16. The 24 is for the flat to flat. There's the flats on the motor here and on the other side. That's what that 24 shows us. The 8 millimeters actually I think is this right here. Oh no, it shows you right there. 8 millimeter on the diameter of the shaft. 7 millimeter flat to flat because it's a hex shaft. So this would be 7 millimeters circumscribed or inscribed? Inscribed, that is correct. And if I wanted the overall diameter of the whole thing, it is right there, 37.5 millimeters. Going back to OnShape, we want to go ahead and make a cut here. Solid, remove, through all, boom. Why did you not do it? Oh, it might help if I told it what I wanted it to do. And I want to merge with all. So, that's not in a very ideal location. This is a very thick part, and maybe I need it to be somewhere else instead. And maybe this thickness right here of 2 inches is too much. How do I get the taskbar to Windows tab back here? So the taskbar will go away so we can see the whole thing. Maybe this thickness over here of 2 inches, I'm getting right there, is way too thick for my shaft to stick out. In fact, I know it is because my shaft is only 23.5 millimeters long from that surface. 25.4 millimeters is the same thickness as 1 inch, so I would be at least an inch away. So we're going to give us a better cut out here. If I click right there, I can see extrude to. That is what this feature is. I can also come over here and highlight, and it will I can hover and it will highlight what these features are. So we're going to edit this, and we are going to do, I wonder if there's an offset from surface option. It doesn't look like there is. That's okay. We'll just do a blind 2 inches, 2.5. So we have a very thin section. And you see, because of how I modeled this, off of this surface, it moved down with it. And if I didn't want that, if I wanted it to stay up there, then I would have had to select maybe a plane or a different surface. If I wanted to move where this motor is, I can come into this sketch. I've selected too many sketches. I can come into this sketch. And right now, this was attached to the origin whenever I made it. And I can see that because right here, it is showing me that the origin is what I have been attached to. So I'm going to click that, I'm going to click delete, and it immediately underdefines everything because it doesn't know where in space I want it to be. So let's say I'm making a side plate, and I want it to be close to this edge of the side plate. So if I change the size of the side plate, it always stays close to that edge. So I'm going to give it a dimension of here to here of 1 inch. And it is still on this plane, which is why it is now fully defined. But it moved that shaft hole with it. So I didn't have to go back and edit both sketches. I only had to edit one sketch, and it moved everything else with it. So I know that that feature, that hole right here, is always going to be moving with these. I always want it in the same spot relative to this. So when I designed the sketch, I designed it relative to those holes. I put reference geometry that connected it to those holes. That's design intent. Are there any questions so far? No questions so far. Excellent. That is pretty much everything I planned on showing today. We can go through more examples and look at some, actually useful things instead of just a blank block somewhere, if that's what we want to do. I'm just going to double check my notes here and make sure that there's nothing else that I wanted to show. Convert could be useful. Say that I wanted to get this exact profile here. I can select that profile, click convert, and it gives me that exact same sketch on this plane. So it's a faster way. Instead of me going through and re-sketching it out every single time, I can just convert. Any questions, comments, concerns? Do we want to maybe take like a 5-minute break and then we can look at some actually useful parts? Or we can call it there. Okay, I think we're going to end the stream there. If there are any questions, feel free to ask. The big why behind everything is what you need to ask yourself when you're designing. Why am I putting this here? What is it doing? If I'm putting a motor in, if I'm putting a pulley in, it's going to be beneficial for me to reference those things off of each other, and so I'm going to design that way. So that's what you have to keep in mind whenever you're designing components. And I think that's going to be it for our stream today. If you have any questions, feel free to leave them in the comments, like and subscribe.